Okay, so on this one you are factoring 5n squared minus 24n plus 27. So step one is to multiply my a and my c, the number in front of the first term and the last number. So 5 times 27, excuse me, is 135, I believe. 5 times 27 is 135. So now I'm looking for two numbers that multiply to give me that number that I just found, 135, and add to give me the b, the middle term, which is negative 24. Okay? So I've got to experiment with this a little bit. I know that 5 and 27 makes 135, but there's no way for me to add 5 and 27 to make 24. So that's not going to be it. Let's see, what else goes into 135? 9 does? Okay, so 135 divided by 9 goes 145, that's 15, 15 and 9. And sure enough, that works. Because 15 plus 9 is 24, so if I make them both negative, they would multiply to give me positive 135 and add to give me negative 24. All right, so the next step is to split up the middle term using those two numbers. So I'm going to write two things that add together to make negative 24n, and those are negative 15n and negative 9n. Put a plus between them even though it's negative. If you were tempted to put a minus here, go ahead and change it to plus negative instead. So this is 5n squared. I'm just bringing down the first term and the last term. All I've done here is I broke up the middle term into two pieces, so that the whole point of that is so that now I have 1, 2, 3, 4 terms. Because the next step is grouping them in pairs. Okay? So here's the next step. I put parentheses around the first two and around the last two. Okay? Then I'm going to take the greatest common factor out of the first pair. What is the biggest thing that goes into 5n squared and 15n? 5n. Don't forget the variable. Okay? And all the ones like this that we're doing, you're going to have a variable come out of the first set. Okay? So you can count on that. So 5n comes out front, and that leaves me with n here because 5n times n makes 5n squared, minus 3 because 5n times negative 3 makes negative 15n. Remember that whenever you take a GCF out to check yourself, you can do distributive property. Now, the second set, it's not necessarily a GCF we're taking out. It's whatever we'll leave behind n minus 3 because these two have to match. Okay, so this is a good example of sometimes you have to kind of play with what you take out. Like if I took out just a 9 here. If I took out a 9, that would leave a negative in front of the n, and I don't want a negative in front of the n. So I have to take that negative with the 9. If I take a negative 9 out, negative 9 times n makes negative 9n. Negative 9 times negative 3 makes positive 27, so that works also. So I need to take out a negative 9. And this is an example of, we wouldn't necessarily think of negative 9 as the greatest common factor because this one doesn't have a negative in it. So sometimes you take out the greatest common factor, sometimes you take out the opposite sign to make the signs work. Okay? I have to make this and this, these two sets of parentheses have to match. Because whatever's in both of them is going to be one set of parentheses down here. So the n minus 3 and the n minus 3 go here. And then everything else, so that's 5n plus negative 9, or just 5n minus 9, goes in the other set. And this is my answer. If I want to check my answer, what do? FOIL. Or distributive property, you can call it. But however you like to multiply your binomials, that's what you're doing to check your answer. 5n times n is 5n squared. 5n times negative 3 is negative 15n. Negative 9 times n. And negative 9 times negative 3. And then these two terms combine. Notice that what I've got right here, these 4 terms, is what I had right here. So that was the whole point of splitting it into 4 terms, is we're sort of backwards doing FOIL. And that is sure enough what I started with up here. So I'm checking, and yes, it does work out to be that. That's not really my answer. Sorry, I put a box around it. This is my answer. This is the factored form.